Hello students, today we going to discuss the topic of 11th class, that is laws of motion. Before to describe the laws of motion, we have to describe some terms like force. It is a push or pull, that is in the form of external effort, which can change or tends to change the or tends to change the state of body. Why this force is required to change the state of body? Due to inertia. It is the inability of the body, which body cannot change its state by itself, that is called inertia. And inertia is measured by the mass of the body. More mass, more inertia, more force is required to change the state of the body. This inertia can be described in three forms: inertia of rest, inertia of motion, and inertia of direction. When the body is at rest, it keep on rest until an external force is applied to change the state. When it is moving, it keep on moving in motion when an external force is applied to change the state. So we need the external force to change the direction of the body, that is due to the inertia of the body. Then upon these two, firstly define Newton's first law of motion. According to this law, a body cannot change its state of rest or motion until an external force is applied to change that state. Means every body continue in the state of rest or motion until an external force is applied to change that state. So this law is also called the law of inertia, or this law define the force. Newton's first law define the force. Then we have the term linear momentum. Quantity of motion contained in a body is called the linear momentum. Vector quantity denoted by P, mass into velocity, measured in kilogram meter per second in SI system. This quantity is defined to describe the Newton's second law of motion. That is, according to this Newton's second law of motion, the external force is rate of change of momentum. The external force is a rate of change of momentum. That is, it is equal to this. If we write here mass into velocity, this is mdv upon dt, and mass into acceleration. So Newton's first law define force, and Newton's second law measured force by measuring the acceleration, that is a change in velocity upon time. By this we can measure the acceleration produced by the body, produced by the external force in the motion of the body. From here we also give the units for force, and for units we have the two system. To define the units, we have absolute and gravitational system. In absolute system, SI unit is Newton and CGS unit is the dyne. And in gravitational, it is kilogram force or kilogram weight, and it is gram force or gram weight. 1 Newton, 1 kg, 1 meter per second square acceleration. Newton is that force which produce 1 meter per second square acceleration in 1 kg. 1 dyne, 1 gram, 1 centimeter per second square acceleration. And how we say kilogram force, 1 kg, 9.8 meter per second square acceleration. Or gram force, gram 980 centimeter per second square acceleration. And from this we can say 1 kilogram force is 9.8 Newton or 1 gram force is 980 dyne. We have to change these forces by using this conversion. Then we have the term impulse. What is this impulse? And before this impulse we have the term impulsive forces. When the forces are constant throughout the motion, we use this Newton's second law to measure that external forces. But the forces which act for a very short time and variable in nature, they are called the impulsive forces. In that case, we measure the effect of force by measuring this impulse, and this impulse is written as force into time, or it is written as change in momentum. So impulse is a force into time and change in momentum. If we use this Newton's second law, dp upon dt, from this we can say that f dt, and if we change in momentum considering for small time t this dt, then it become p2 minus p1, and this may be considered as average force, which for this variable motion consider as a constant, the force into time, and then this is called the impulse. So impulse is a force which measure the effect of, impulse is a term which measure the effect of the variable forces which are variable in nature. These impulse can be measured by, if we have the graph, this is the constant force graph, force and time, by measuring the area under this graph. This area is length into breadth, and when we measure this area, this become force into time, and force into time is called the impulse. This is for the constant force. And if we have the variable force in the shape of this graph, then how we calculate this force and time graph for variable force? Again by measuring the area of this strip, then by taking whole area, this integration 0 to t f dt, or area of this whole part under the graph, area under force time graph gives the impulse. That will be give us the impulse. And we have so many examples for the impulse, like why the bowler lower his hand to catch the ball, because if this change in momentum takes large time, then the effect of force is small. But if this change in momentum takes small time, there is a very large force which give this change in a very short time. So for that, the cricket player, bowler lower his hand to catch the ball. Car, buses, we have the shocker systems, bogies of trains, or any person falling on the cemented floor get hurted more than on the loose sand, because in that the time of impact is increases and the force of impact is decreases. Then we have Newton's third law, that is Newton's third law is, to every action there is equal and opposite reaction, and these two action and reaction forces are equal and opposite, but they never cancel each other because they are acting on the two different bodies, and they always act simultaneously at the same time. So out of these three laws, Newton's second law is the real law of motion, because by using this law we can explain the Newton's first law and the third law. Like this, we have this force is mass into acceleration. If we say F0, mass into acceleration 0, mass is not 0, acceleration is 0, means v minus u upon t0, or v0 means initial velocity is equal to the final velocity when there is a no external force. That is called the Newton's first law, and this first law is described by using this Newton's second law. And from this law, how we get the third law? If we say that we have an isolated system with two bodies, A and B with the two bodies, we have the isolated system. And if we say that they no external force because the system is isolated, but A, due to mutual interaction, A affect B, change the momentum of B, then B affect A, change the momentum of A, and if we considering it AB plus BA, that is equal to dt P1 plus P2. But when the system is isolated, no external force, the change in momentum is zero. Keep in mind, when no external force, the total change in momentum is zero, or we can say action is equal to the reaction. And we have the so many examples in daily life for swimming, for walking. When the ball drop, it rebounds upward, and the person jump from the boat is moved backward. They all are the examples of the Newton's third law of motion. And in this we also have the connected motions, where we use the pulley problem. This is also the some examples for this. We have these two masses connected to the pulley. We say that m mass, small m mass, mg downward. In both cases tension is upward, but the m mass is more than small m, so the system is moving with this common acceleration. And when we describing these equations, what we use here, tension minus mg is mass into acceleration. For this, downward force is large because the motion is downward, ma. When we add these two equations, what we got here, we got here m minus mg is m plus ma, and by using this we got this acceleration, that is m minus mg upon m plus m. So by using this equation we calculate this value of the common acceleration for this connected system. And if we dividing these two equations, then we got the tension, that we have 2mm upon m plus m into g. This is the tension of this connected motion when we dividing these two equations that we got from this connected motion problem. There is one more example here, that we have the apparent weight of the person in a lift. In a lift, if the person is standing on the weighing machine, the normal reaction gives the weight of the body, but the normal reaction is called the apparent weight. When the lift is at rest or it is moving with some constant velocity, then there is no extra acceleration and the reading is equal to this, r is equal to mg. When the lift is upward accelerate with this acceleration, then the net force become reaction force minus mg, and this is the net force ma, r minus mg, and now the reading become a plus g, or we can say g plus a. We can write like this because this is the already weight g and the acceleration is added to it. So when the lift is moving upward, the normal reaction or the apparent weight increases. When the lift is moving downward, then what we say that this will become mg minus f, or this is mg minus a, means that acceleration is decreases to this, or the apparent weight of the body is decreases. When g is equal to when a is equal to g acceleration, then the apparent weight becomes zero, or the body come out to be in the state of weightlessness, where the weight is not considering. So this is the situation for this laws of motion, third law of motion. Then we have the law of conservation of linear momentum. How we describe the linear momentum? Linear momentum is a quantity of motion contained in a body, but when we say that law of conservation of linear momentum, then we say that conservation of linear momentum, F is dp upon dt. If F is equal to 0, This change in momentum 0 or p is constant, means the momentum is conserved when there is a no external force, or we can say for an isolated system momentum is conserved. And for this conservation, so many examples: recoiling velocity of gun, when the bullet is fired, bullet is moving forward but the gun recoils backward with some velocity, that is called the recoiling velocity of gun. If we say that momentum of gun, momentum of bullet 0, this is before firing, this is after firing, and after firing what we got, the velocity of gun recoiling backward, this is called the recoiling velocity. So by firing this by firing the bullet, the gun must be held tight to the shoulder so that the backward motion is combined with the shoulder motion and the effect is decreases. Explosion of bomb, the based on the conservation, the before explosion momentum of bomb is 0, so the segments fly off at the different positions or directions to conserve the momentum. And the rocket propulsion is also based on this conservation of linear momentum, and we use this rocket propulsion to describe the to find the velocity of rocket by using this law of conservation of momentum. If we considering that at t equal to 0, this is the initial mass of the rocket with fuel, initial velocity of the rocket, but at time t this become the mass, this become the velocity. For small time this, the mass is decreases and the velocity is increases. So for this small mass, this is the exhaust gases. If we say that this is the rocket, fuel, burning and exhaust gases, if this mass is exhaust gases, it again has some velocity, that is called exhaust gases velocity. But it conservation of momentum, at any time this momentum is m minus dm v plus dv plus dm minus vg, exhaust velocity. This is mv plus mdv minus vdm minus dm dv minus vg dm. So we neglect it, and what we got here, we got the term vgdm, and here we say it relative velocity. And by using this, how we write this this dv minus u dm upon m, we integrate this term, this is initial to final, this is initial to final, and we got the velocity initial to final minus u log e m naught to m. Then we get v minus v naught minus u log e m upon m naught, or we can say v is equal to v naught plus u log e m naught to m, or this is called the velocity of rocket at any instant. Initial velocity is 0 mostly, so this is u log e m naught to m. If the whole fuel is burned out, it got the maximum velocity, that is called burnt out speed, or the mass left is the container mass, and this is called the burnt out speed of rocket. And if we want to find the thrust on rocket, we take again this equation, divide by dt, this is called acceleration, so mass into acceleration dm by dt, and this is called the force or the thrust exerted on the rocket, that is minus u dm upon dt. Then we have the congruent forces, which are the forces acting at a same point, and these forces are in equilibrium when their net resultant is 0. So this is all about the term force, related terms, momentum, conservation. Then in this next we have the friction. Friction is the opposing force that oppose the motion. Motion, relative motion, when one body try to move the surface of another body, there is an opposing force which opposes this relative motion, that is called the friction, that is called friction. And this friction is of considering three types: static friction, limiting friction, and kinetic friction. So the old theory says roughness is the cause of friction, but when the surfaces become extra smooth, friction is again increases. So the modern theory says that when the surfaces are in contact, either they are rough or they are at the extra smooth surfaces, there are the actual point of contact where the maximum atomic molecular forces arises, maximum atomic and molecular forces of attraction arises, that will be cause the friction. This is when the body is at rest, and it is a self-adjusting friction. When we apply the force but the body is in the state of rest, this is called static friction. Limiting friction is the maximum value of static friction is called the limiting friction, and this is when the actually motion is started and the body start moving with some velocity, then there is a friction, that is the kinetic friction, and it is further that is written as this further is written as sliding friction and rolling friction. Means when the body actually start moving on the surface of another body and it starts sliding, this is called the sliding friction, and this is called the rolling friction. And for rolling friction, if we say the wheel, there is a form of this depression, and frictional forces are adhesive forces, the attraction between different molecules. But here this force, this depression or this bump is the cause. When this wheel is moved out from it remove away from this attraction, and this cause the rolling friction. And if we draw this graph, the graph shape is this, and this is called friction force, and this is the applied force. Then we say this is static friction, which adjusting itself with the applied force. The maximum value of static is called limiting friction, when body is at the verge of moving, and this is called the kinetic friction, because when the actual motion is started, work has to be done to maintain that motion, because the kinetic friction is present over there. And we have the laws of friction in and it's the tangential force always act parallel to the surfaces, and it always act opposite to the impending motion direction. And there is a one very important law, that this force of friction is directly proportional to normal reaction. And here we have the coefficient, that is called coefficient of friction. And when we saying that static body is not moving, that is the static coefficient of friction, static force of friction, and kinetic force of this kinetic coefficient of friction. It's just a number, it has no unit and no dimensions. Then this is called coefficient of static friction when the body is at rest, and this maximum force is directly proportional to normal reaction, and this is called the kinetic force of friction. Then we have the term angle of friction. Angle of friction. When a body start moving, when there is a body placed on the surface, weight downward, normal reaction upward. If we try to move the body in this direction, applied force, we apply the force in this direction, there is a friction between these two surfaces, that is called friction. So the resultant of normal reaction and friction makes with the normal reaction angle is called angle of friction. And this here, if we say tan alpha is F upon R, and this F upon R is called here static friction mu S. This is angle of friction. The resultant of friction and normal reaction makes with normal reaction, and the term is angle of repose. This is very important term when we considering this motion, that is the inclined plane. We place the body, weight is downward, normal reaction, it convert into two forms, mg cos theta, mg sin theta. Now this is the angle, minimum angle of inclination at which the body placed on the inclined plane is just sliding, slide beginning the just sliding. Mg downward, normal reaction is mg cos theta. When it start moving sliding downward, there is a friction upward, and this friction is mg sin theta. And again, if we have the tan theta, this mg is f upon r, and this is called the coefficient of friction, that is f upon r is called again the coefficient of friction, that is mu s, because body is just sliding. This is the sliding coefficient of static friction. So this tan alpha is mu s, tan theta is mu s. So alpha and theta, they are both numerically equal forces, and this friction is a necessary evil, because the friction is there are some advantages. We can't bind the things without friction. It is adhesive force, can't writing the surface, can't move anything, not anything. So friction is required there. But in some cases, this friction is a dissipative force, and the energy wasted against it cannot be recovered by us. So there are some methods, by polishing, by converting it, the sliding into rolling, by proper selecting of materials, streamlining the bodies by taking the different shapes, proper shapes. By selecting the materials, we can minimize this friction. And in this case, how we calculate the work done? If we want to move this block that is placed on horizontal at some distance, this friction force is mu r, and this is mg. So applied force must balance this force, and if it covers some distance, then work done is force into distance, matlab mu mg s. This is the simple work done when the body is moving on a horizontal surface by taking this, because the applied force is balanced, at least it is equal to the frictional force. But when we considering this inclined motion, then how are we considering this applied force? Here we have this applied force when the body is moving upward, the friction is downward. If we considering, this is our body having angle theta, mg, normal reaction, two components, mg sin theta, mg cos theta, and we say that body is moved upward move. This is the applied motion. Then friction is downward. So this applied force is mg sin theta plus f. Then what is this f? Mg sin theta plus mu r, and r is here mg cos theta. So mg sin theta plus mu mg cos theta, or we can say the applied force is mg sin theta plus mu cos theta. And what about the work done? If this length is s, work done is mg sin theta plus mu cos theta into s. But if this inclined plane body is moving downward, then what we say? Mg reaction, mg sin theta, and here we have mg cos theta, and now body is moving downward, so the friction is upward. Then the applied force is at least equal to mg sin theta minus f, or we can say mg sin theta minus mu mg cos theta. And what we say, the work done, mg sin theta minus mu cos theta into s. This is the work done when the body moving just upward, and when the body is moving downward, body is moving and the friction is up. Okay, thank you.